school level, science exhibition is intended to demonstrate scientific concepts through still models, charts, and posters. These exhibitions explore and encourage scientific and technological talents among the students and help to bring out the future scientists into the limelight. A very delightful morning to one and all. I, Master K. D'Souza, with my co-host Suchi Ludhani, welcome you all to the most prestigious event of our school, the Sky Youth Science Exhibition.
Presenting my science exhibition topic, that is a Newton's cradle, and or also called as colliding balls. The aim of this topic is to demonstrate the law called as conservation of energy or conservation of momentum. The material required for the making of this project are a few ice cream sticks, few marbles, thread, a glue to stick them all. History of Newton's cradle. It was invented in 1967 by an English actor, Simon Preble, also and named in the honor of mathematician and scientist Isaac Newton, because it employs Newton's law. Observation. When the balls or the marbles collide with each other, they transfer the kinetic energy to the next, which leads to the upliftment of the last ball. Conclusion. When one spear is lifted and released, it leads to the striking of the stationary spears, transmitting their forces to the next, which leads to the pushing of the last ball upwards. This is all because of the law called as conservation of energy or conservation of momentum. Thank you.
Hello respected teachers and my dear friends. I'm Navya Shetty, student of class 9C. As you can see, I've made a working model of a hydraulic robotic arm. It is made based on the Pascal's law that states that any pressure applied to a closed system, the pressure will be transmitted equally in all directions. Hydraulic refers to a liquid moving in a limited space under pressure. The word hydraulic is derived from the Greek word hydraulikos. Hydro meaning water and olos meaning pipe. It helps engineers perform various tasks. Let's see how my model works. When I push or pull the plunger of the first syringe, water is forced into the second syringe, thus extending its second plunger, which is connected to the mechanical arm and thus moving it. In my model, I've made it out of 4 parts. First is the blue one, which helps me to move the hind arm of the mechanical arm. The purple one is for the movement of the forearm. The green one for the claws, while the pink one is to move the whole arm. Now with the help of a paper cup, I will be demonstrating how the mechanical arm works. My model is made out of cardboard, toothpicks, clay, syringes, pipes and water. This mechanism is used in various cranes and other big engineering machines. how my mechanical arm works. Thank you for your patient hearing.
Hello friends and respected teachers. I am Master Ved Anil Satam from grade 9D, New Horizons Scholar School, Airoli. So here I have prepared a model of a weather indicating flower by using a blotting paper and dipping it in a very concentrated solution of cobalt chloride compound. So this question might have arisen in your mind that why I have used only cobalt chloride. I have used this compound because it is very sensitive to humidity and changes its color accordingly, and hence it fulfills all the requirements for detecting the weather. Now let's check how it reacts to dry weather, that is very low humidity. As you can see that the color of the flower has turned to blue. So from this we can conclude that the color of cobalt chloride turns to blue when it is exposed to dry weather, that is low humidity. Now let's check how it reacts to high humidity, that is the rainy weather. So you can see that the color of the flower has turned to bluish pink. So here we can conclude that cobalt chloride changes its color to bluish pink when exposed to high humidity, that is in the rainy weather. Now this, my dear friends, is just a demonstrative apparatus, but in real life this concept is used in weather institutes to detect the climate. So I would like to thank you all for your kind attention.
Hello everybody, my name is Yatha Dhuran and I am from grade 9D.
We all know that the salt water is a great conductor of electricity. So today I am going to prove it to you. So let's get started. The things we need to do this experiments are a 2 volts bulb, some salt, some water, a spoon made of metal and a glass made of metal. So I'll now let you know the wire management I have done. So there are 2 wires connected to this bulb. The other end of the yellow wire is directly connected to the electricity board from where the electricity is supplied. And the red wire's other end is connected to this spoon made of metal. And there is also one extra wire, that the one end of this red wire I have connected to this glass, and the other end of this red wire I have connected directly to the electricity board. So now I am going to pour this water in this glass And now I'm going to add some salt in it. Now I'm going to mix the salt. Now I'm going to on this switch.
Hello everyone. Today I Parth Gondalia of grade 9th D will explain you the working of an electroscope. Electro and scope, both word combines and form electroscope, in which electro refers to electricity or processes involving electricity, while scope refers to scanning. So it basically means a device or instrument which is used for detecting or determining presence of charges by the means of electrostatic attraction and repulsion. Electroscope was invented by famous British physician William Gilbert in the early 17th century. It was the first electrical measuring device and was named versorium. Electroscope is also helpful in learning the principles of electrostatics. And the basic principle of electroscope is like charges repel while unlike charges attract each other. As you can see, this is my improvised electroscope, which has a glass jar, plastic cover, a conducting wire and two foil leaves. I have used a glass jar so that the static energy cannot pass through it. A plastic cover for the same reason. I have used a conducting wire to transfer charges from its top to the leaves. The leaves are made up of foil so that they allow the electric charge to flow through them. I have also covered it with a foil paper so that it can amplify its ability to collect charges. So let's try it. As you can see, this is a balloon, and when I rub this balloon and bring it near to the electroscope, the leaves start to repel each other. You can see that I am not touching the balloon with its top, I am only bringing it close to it. Then too, the charges are getting transferred. This is due to electrical induction. So it proves that whenever I bring the balloon to it close to its top, the like charges get concentrated on the end of the both of the leaves. So as they both of the leaves have same charges, they repel each other. Thank you.
Hi everyone, my name is Nivya Chordekar and I am from grade 9th. Today I am going to perform an experiment about natural indicators. The materials required for this experiment are turmeric, detergent, lemon, water, glass and a spoon. First of all, we'll start off by adding turmeric in a glass. Turmeric is a natural indicator and it's yellow in color. Now we will add water into it. Now we will stir it for 2 to 3 seconds. As we can see, the solution has turned to yellow in color. Now we will add detergent into the turmeric solution. Detergent is a base. Now we will stir it for 2 to 3 seconds. As we can see, the solution has turned to reddish brown in color because of the presence of base, which is detergent. Now we will squeeze lemon in the solution. Now we will stir the solution again. As we can see, the solution has turned back to yellow in color because of the presence of acid in lemon. Turmeric is yellow with acids and changes to reddish brown in color with bases. Thank you and have a nice day.
Materials required are a glue gun, a soldering machine, a switch, a battery case, a DC motor, a chuck, connecting wires and batteries.
This is our project mini drill completely assembled. Firstly, we attach the batteries into the battery case. Then we attach the switch with the hot glue gun to the battery case. Then we attach the DC motor to the battery case with the hot glue gun. Then we connected the wires with the help of soldering. We connected the DC motor to the battery. We connected the switch to the battery. We connected the DC motor and the switch with each other. Then we attached the chuck to the DC motor. Now let's check out its functioning.
Thank you and have a nice day.
Hi, today I am going to demonstrate how this DC generator works and also explain how it does so. So let's get started. We will need a nail, some washers, some nuts, an ice cream stick, a rubber band, a motor, an LED light, a screwdriver and a wooden structure like this. So, first of all, it converts the muscular energy into mechanical energy and then to electrical energy. That glows this bulb. Let's see how. Now, how does that happen? Basically, there is an electrical conductor in this motor that is called the armature. When an electrical conductor is in motion with respect to a magnetic field, that is the magnets inside the motor, an electric current is induced that glows the light bulb. Now let's talk about its constituents. From this apparatus, only the motor and the light bulb is ready-made. Apart from that, everything can be found at home. This wooden structure was purely made from waste wood and the CDs are also recycled. Thank you.
Hi friends, my name is Yashanand Kesarkar and I am from grade 9G. My ID number is 2100. I am going to show you science experiment on hologram projection. Hologram is a three-dimensional image created with photographic projection. The theory of holography was developed by Daniel Jaeger in 1947. A 3D hologram displays product, object and animated sequence three-dimensionally and enables seemingly real object or animation to appear to float completely freely in the space. 3D hologram is visible for all sides, which means the observer can walk around the hologram, enabling an realistic-looking image to form. How hologram projector works? Hologram projector use hologram rather than graphic image to produce projector picture. They shine special white light or laser light onto or through holograms. The project light produce 2 or 3 dimensional images. Now I will show you how it works. It looks like this.
Light is a simple and yet a complex phenomenon. It is powered by the weak nuclear force, which is one of the 4 fundamental forces. Light travels at a speed of around 300,000 kilometers per second, making it the fastest object in the universe. Object? Well, light is both a wave, which is a phenomenon, and an object. It has a wide spectrum ranging from the sluggish radio waves to the killer gamma waves. Light observes rectilinear propagation, that is, it travels in a straight line. However, this is defied when a ray travels from different media, that is, from gas to liquid, liquid to solid, etc. When light travels from rarer to denser media, it bends away from the normal and vice versa. Here are 3 liquids: pure water, coconut oil and soap water. Of these 3 liquids, coconut oil has the least density, followed by pure water and soap water respectively. This is the straight line of light, which is known as normal. When we place the container of pure water in front of the laser, the light is deflected in a direction which is above the normal, We will take this as a base because pure water has a relative density of 1. When we place the container of coconut oil, the light is deflected in a direction much higher than both the normal and the base. This is because there is a lot of difference between the densities of coconut oil and pure water, as coconut oil is much lighter than pure water. When we take the container of soap water in front of the laser, the ray is lower than the base but higher than the normal. This is because soap water has a higher density than pure water. Thus, refraction exists in all liquids. Thank you.
What an insightful experience put together by our young scientists.
India has been a home to some marvelous scientists, and their inventions, right from Dr. APJ Abdul Kalam's missiles and nuclear weapons to Sonam Wangchuk's latest ice stupa. And we here at New Horizons Scholars believe in sowing the seed of invention for the better future of our world.
On this note, let the creativity and inquisitive minds of our young magicians and future scientists make this world a better place with their young and fresh ideas and perspectives. Keep the magic of curiosity and inquisitiveness alive in you. Thank you.